All right, in section 10.1 here, we're going to be talking about conic sections. In particular, we're looking at parabolas. And so instead of the traditional definition of a parabola, that's going to be defining the x and y coordinates just based off of the relationship between x and y. We're going to be talking about the relationship between the vertex, the focus, and the directrix. Okay, so first of all, what is a focus and a directrix? So the idea is that the focus and the directrix define all points in the parabola. So any point on the parabola is supposed to be equidistant between the focus and the directrix. So if I pick any point, the distance between the directrix and the focus is supposed to be equal. Now, if I've drawn it correctly anyway, and so mine's just a rough estimate of what it should look like, but that's the idea. So you can see that on the vertex, at least, hopefully that does look like I have drawn that correctly. They should be equally spaced right there as well, equidistant between the focus and the directrix. And again, at every other point, equidistant between the focus and the directrix. And so that's a way to write the equation, or to get the equation written, so I can find the focus and the directrix. So I've got some notes over here in a Word document I'm going to pull up for a second about parabolas. And so if you have your parabola in the form x minus h squared equals 4 times p times y minus k, the vertex is going to be identified as h comma k, and then you can use that p value to identify the focus and the directrix. I'm going to write those down, and then we can talk about finding those. Oops, goodness. There we go. Okay, well, there we go, that's what I wanted. Okay, so the equation, I want to get it in the form of x minus h squared equals 4p times y minus k, and if it's in that form, then we're going to know that the vertex is h comma k. This is similar to just completing the square and writing something in vertex form, except that it's factored a little differently on the y side than it would be if I had just gotten it in vertex form. And so the focus, okay, so the focus is p units up from the vertex, So if I just add p units up from the vertex to the y coordinate, the focus is going to be h comma k plus p. Then the directrix is p units down, it's a line, so it's y equals k minus p. Okay, so let's find an example and take a look at one of these. So I'm going to start with x squared plus 6x plus 4y plus 5 equals 0. We're going to identify the vertex, the focus, and the directrix for this. Okay. So the first thing to do, I'm going to complete the square on these. So I'm going to move the other two terms to the other side. So we're going to start with x squared plus 6x equals, and we're going to subtract the 4y and subtract the 5 to the other side. And now we need to work on completing the square for the x's. So if you remember from completing the squares, we want to find an n value that is b, I'll just put b, I was going to put 6 because that is b, but b divided by 2. So in this case, it's 6 divided by 2, so 3. And then I want to know what n squared is. N squared is 9. And n squared is what I add to both sides. Okay? And once I've added that to both sides, I have x squared plus 6x plus 9 equals negative 4y plus 4. I add n squared to both sides to make it a perfect square. We're trying to complete the square, so we're going to add that perfect square value to both sides to make this factorable. It should be factorable now as x plus n squared. So that's our n value, x plus n squared. The n value is going to be inside of our parenthesis here. And if you just double check, 3 times 3 is 9, 3 plus 3 is 6, so it multiplies back out if you were to expand it. So that's how we complete the square, just a memory on that. And the other side, we want to factor all the way out until our coefficient of y is 1. So we're going to factor negative 4 out and get y minus 1. Okay, now it's in the correct form, and so I just want to identify what h, k, and p are. So first of all, h is, I've got the opposite. This is supposed to be x minus h. So I need x minus negative 3 here. So the opposite is going to give us an h value of negative 3. The p value, this is supposed to be 4 times the p value, gives me negative 4. So the p value is negative 1. And then the k value. So again, it's y minus the k value, so it's y minus 1, so the k value is 1. With those three things, we can list our vertex, our focus, and our directrix. So our vertex is going to be at -3, 1. Our focus is going to be, okay, so the focus is going to be -3, because I keep the same x coordinate, and then I take p and add it on to my k value. So 1 plus -1 is going to be 0 for the y coordinate of the focus. And then the directrix is a line, y equals, and it is k minus the p value, so 1 minus -1 is going to be 2. Okay, so if we try drawing this, we have a vertex at -3, 1, so -3, 1. I have a focus at -3, 0, and I have a directrix at y equals 2. So every point on the parabola is going to go through the vertex, but every point on the parabola is going to be equidistant between the focus and the directrix. If I pick a point, it should be the same distance between the focus and the directrix. I don't have a ruler to measure those handy, but hopefully they are close to the same if I've drawn this correctly. If I had a rod with some string and I could push pin it to the focus, then I would be able to take that string and accurately pull it along the rod to get my parabola drawn exactly by hand, which is how they used to do them in a long time ago. Okay, so let's look at another one. Okay, the next one that I want to look at is, oops, not too big, there we go. It's going to be the horizontals. So the horizontal parabolas, okay, so that we have the vertical axis of symmetry, a parabola that faces upward. The horizontal axis of symmetry means that the parabola faces sideways. They're going to be very, very similar. X and Y are trading rules right here. Y is going to be squared. You're going to complete the square on Y. Then your vertex is still h, k, and then your focus is going to be heading to the left or to the right. And so you're going to be adding p to the x coordinate instead of the y coordinate, and subtracting p from x instead of y, because your directrix is going to be vertical. But very, very similar process for horizontal, but we'll give one of those a try as well. All right, let's take a look at another example here. And let's go with the equation y squared minus 2y minus 8x minus 31 equals 0. And it's the y that is squared this time. So I want to get the two y values on the same side, everything else moved to the other side. So y squared minus 2y equals, add those over, equals 8x plus 31. All right, and now we're going to complete the square with the y's. So we're going to find our n value, which is -2 divided by 2, so -1. And we're going to add n squared to both sides. So add 1 to both sides. So this gives us y squared minus 2y plus 1 equals 8x plus 32. And if I factor this, this is going to be y minus 1 quantity squared equals, factor out the coefficient of x, so 8x plus 4. Okay, one more rewrite, just to make sure that p is going to be easy to see. We find p because we can factor a 4 out of here. This is 4 times 2 times x plus 4. And so now we should be able to identify all of the values. Okay, so our p value is 2. Our h value associated with x is -4. Our k value associated with y is 1. Opposite of -1 is 1. Okay, so that means that our vertex, the x coordinate is -4, the y coordinate is 1. Then our focus, okay, we're going to add our p value to our x coordinate. So our p value added to our x coordinate gives us -4 plus 2 is -2, comma the k value of 1, and our directrix. So this is an x equals line, and we're going to subtract from the x coordinate our p value, so -4 minus 2 is negative 6. So if I make a sketch of what this should look like, we've got negative 4, 1, and then we have negative 6 as the directrix. I drew that one first, and the focus at negative 2, 1, and so a quick sketch of that parabola. And again, at any point you should be equidistant between the directrix and focus, so hopefully that looks pretty close right there. We've got our focus on the inside, our directrix out here, and we're equidistant at any point. Alright, so I'm going to take a look on Desmos, just graph this one, kind of see how the parts look up in an actual graph. There we go. Oops, where's my Desmos window? Oh, it's just off to the side here. Got it. Alright, so I'm going to type in what I found. I found y minus 1 squared equals 4 times 2 times x plus 4. And we have a vertex at negative 4, 1. And I can even label these. That's our vertex. And then I have my focus at negative 2, 1. And so that's the focus. And then we have x equals negative 6 as our directrix. And again, that's not part of the graph, so we're just going to dash that in. But the idea is that any point on the graph, no matter what it is, should be equidistant between the focus and the directrix. If you imagine a line connecting, I'll just click on that point because it'll stay. If I connect between the focus and the directrix, they should be equally spaced, and that's how all of these lines have been formed.